All right, folks, I've got the book open for me right now to page 38. This is P.4. There's a lot of things on this in this section that are really simple and intuitive and things that you already know. And then there's also a few things in this section that are a little bit different that we've never really talked about. So there are a couple things that I'm really going to make sure that we talk about and go more in depth on. And then there are also some things in here that you already know how to do, and I'm not really going to waste too much time talking about them. So for instance, if you would open your book to page 38 and look at it, the first thing that they want you to be able to do is to determine if a solution or if a point is a solution or not. And if you're given an equation, the equation that they give you is y equals 10x minus 7, and they ask you if something is a solution, you plug something in for x, you plug the other thing in for y, and then you just solve. If it works out to be the same thing on both sides, then you're good. If it doesn't work out to be the same, then it's not a solution. So that's, again, something that I'm not going to go over. The next part says to sketch a graph of an equation. You all know how to graph a line. That's what section 2 is about. This one specifically has you put it in a table. I'm not going to put it in a table. You know how to graph y equals mx plus b, and since you know how to do that, we don't need to talk about it. The part 3 is the same thing with quadratics. Again, you know how to graph a quadratic, so we won't spend any time talking about that. The part that I think is kind of important, and I want to make sure that we at least know how to do, and we maybe know how to do them already, but I want to make sure that we understand the what x and y intercepts actually are. So if you look at example 4 is all about finding the x and the y intercepts. And remember, remember an x-intercept is where the graph crosses the x-axis. And then the y-intercept, obviously, we all know this one from y equals mx plus b. This is where the graph crosses the y-axis. My handwriting looks like a kindergartner's. But the x-intercept is where the graph crosses the x-axis, and the y-intercept is where the graph crosses the y-axis. The really important part about the x-intercept is that this happens when y equals 0, and the y-intercept happens when the x equals 0. So if you're asked, and what the way they work through this for you is, if you're asked what the x-intercept is, you have to just plug in y equals 0, and then that'll tell you the x-intercept. If you're asked what the x-intercept is, you plug in x equals 0, and it'll tell you the x-intercept. Pretty straightforward stuff. Should be stuff that you already know how to do. If you want a good example, look at page 41. That has a very good example that'll walk you through it. Okay. The part this next page, page 42. This is where things really kind of change from what we were used to, what we're used to seeing. Okay. There are 3 types of symmetry that they specifically talk about. The 3 types of symmetry that they use are symmetry over the x-axis, symmetry over the y-axis, and symmetry around the origin. Okay, so what they're essentially looking at here is, if I have a graph, if I have symmetry across the x-axis, that means if I have a shape that looks like this, it will have a mirror image shape. As much as I can draw a mirror image, it'll have a mirror image shape. This is x-axis symmetry. Okay. If I have the same kind of idea, I can't even draw a straight line. If I have the same kind of idea where I draw something that looks like this, the y-axis symmetry would be something that mimics that. I don't know why I can't draw on this thing. The y-axis symmetry would be something that mirrors that the other direction. So the black line and the red line would mirror over the x or over the y-axis. That would be y-axis symmetry. And then the last one, this one's probably the most complicated one, but it's the one that makes kind of the most sense, if that makes sense. It's a combination of both the x and the y-axis symmetry. So if I look at something that looks like this, the origin symmetry would be something that looks like this, because if you notice what really happened, if I take this step at a time and I say, okay, this is y-axis symmetry that looks like this, and then if I were to reflect that blue line over the x-axis symmetry, it looks the exact same. So the origin symmetry is essentially just these 2 things put together to create this one. Okay. The easiest way to test those, if you look in your book, it kind of tells you, but if you want to see if something is an x-axis symmetry, all you have to do is everywhere you see a y, plug in negative y. When you plug in negative y, if it works out to be the exact same as what it was before, then your equation has x-axis symmetry. If you're doing y-axis symmetry, if you plug in negative x and it comes out to be the exact same that it was before, then it's going to have y-axis symmetry. And then with origin symmetry, you're going to plug in both of them because we just said it has to do with both of them. So you're going to plug in y-axis or negative y and negative x to see if it has both. Okay. So if we look at an example of this, so if we look at something like, let me find a different example that's not in the book, or that's not where we had, or not from this, can't even talk. So if we look at something like number 43 in the book, actually let's do an odd number or an even number. So if it says like y equals negative x squared minus 2x, it asks us to identify what kind of symmetry this has. It wants us to test symmetry. It actually asks us to find the intercepts too. And if you want to find the intercepts, what you're going to do is just plug in 0. So you're going to plug 0 into here. Okay, I just wrote the word of. You're going to plug in 0. Come on. And then you're going to solve for x. So you're going to get, oh, hang on. My pen went crazy. So you're going to solve this. We all know how to solve that equation. You would factor out the x, you would solve, good to go. If you want to find what the y-intercept is, you would just plug in 0 for the x's. So you would end up getting y equals negative 0 squared minus 2 times 0, and then you would find out that y equals 0. So that's how you would test for the intercepts. If I want to test for symmetry here, what I'm going to do if I want to test for x-axis symmetry, I'm going to plug in negative y. So when I plug in negative y, I'm going to get negative y equals negative x squared minus 2x. And I'm going to see if there's anything I can do to that, which will make it simplify down to say what the blue equation up here says. And there's nothing I can do, right? I could divide by negative 1 if I wanted to, which if I divide by negative 1, I'm going to be left with y equals x squared plus 2x. But there's nothing else I can do to simplify this. So there's nothing that can be done. If I want to test, so that means if it's not x-axis, that means it can't be x-axis symmetry and it cannot be origin symmetry. It can't be either one. So then if I want to look at y-axis symmetry, I'm just going to do the same kind of thing, but I'm going to plug in negative x. And I should have put this in parentheses over here. So I should have said negative y. And then for y-axis symmetry, I'm going to plug in negative x into my equation. So I'm going to do y equals negative and then negative x squared minus 2 times negative x. So when I plug this in, negative x squared will just come out to be x squared. So this is going to be negative x squared. And then negative 2 times negative x will end up being a positive 2x, which notice that is not the exact same thing as what's in the blue. So since it's not the exact same thing as what's in the blue, it will not be any symmetry at all. It actually won't have any symmetry at all. Okay, so just kind of keep that in mind that isn't going to have any symmetry. Okay, I'm going to pause just for 1 second. Okay, I'm actually coming back because I think I just misspoke. I said that if something is not one of the two symmetries, it can't be the other one. I don't think I'm sharing my screen with you right now. So I said if something is not one of these two symmetries, it can't be the other one. You still have to test it because sometimes there's things that happen to one and the other one, and when those two things work together, it sometimes makes it so that it reflects. Okay, it's kind of a weird scenario, but let's test it just to make sure that it either does or does not work. So if I want to test for the origin symmetry, I'm going to plug in negative y for y, and I'm going to plug in negative x for x. Oops, the negative there. And I'm going to plug it in everywhere where I see an x, and I'm just going to simplify this to see what I can simplify it down to. Okay, so what that means is I'm going to have negative y equals negative x squared becomes positive x squared, so I'm going to get negative x squared, and then negative 2 times negative x will be positive 2x. And now the only thing I could do is divide by negative 1, and I'm going to be left with y equals x squared minus 2x, and that is not the same thing that it was originally. Since it's not the same thing that it was originally, that means this will not have any symmetry, not axis, not x, not y, not origin. So it won't have any of them. Okay, so hopefully that makes sense. I'm going to give you a couple of those to try out to make sure that you understand them, but it's basically just simplification. That's essentially all that it is. The next part that we're talking about in here is equations of circles. What I want you to know with equations of circles, it is given by this x minus h squared plus y minus k squared equals radius squared. H and k is the center of the circle. So it's the exact same way that we did everything with h and k last year. So remember, inside parentheses, it moves it to the right if it's negative, to the up, down if it's negative or positive. So it's the same kind of thing that it always has been. Okay. So remember, when it's inside parentheses, it's always the opposite. So for instance, one question in the book, it says that you have a center at -1, -2. So it tells you there's a center at -1, +2. And then it says there's another point, and that other point is at 3, 4. So there's a couple things that you have to do here. First, we know that the center is -1, -2, or -1, +2. So that can get plugged in right there, but we don't know the radius. If I think about just a normal graph and I put a point at -1, +2 here, and then I know I have another point at 3, 4 here, my circle is going to go through that point just like this. The distance from the center of the circle to that point is going to give me my radius. So the way that I'm going to figure this out is by the distance formula. So I'm going to use the distance of, and this is from P.3, I'm going to do x2 minus x1, so 3 minus -1 squared, plus y2 minus y1, which is 4 minus 2 squared. And then I'm going to simplify that, and I want to leave it in its radical form, because I'm going to plug my radical back into here, and when it gets squared anyway, it's going to be easy. Okay, so this is going to be the same thing as 4 squared plus 3 squared. Is that right? 2 squared? It's not 3, it's 2. So that's going to be the square root of 20. And now I know that r is 20. So when I plug that back into my entire equation, I'm going to have x minus h. So x minus -1 would be x plus 1 squared, plus y minus k, y minus what k was 2 squared. And then I'm going to put equals the square root of 20 squared. And then that will just simplify down to give me 20. Okay, that's the equation of a circle. Again, I know you did that in geometry, but just to kind of make sure that you understand what's happening. Okay. That's pretty much all that we're going to do here. Everything else I don't think is super important. So make sure that you check Google Classroom to find some applications and some things that I want you to kind of test and make sure that you understand. But basically all this is getting comfortable with functions again. Being able to use functions, being able to solve things with functions, and just trying to make things so that they're straightforward. Okay. If you have any questions, make sure you let me know. Check Google Classroom to find the homework problems that I want you to attempt. And then if anything pops up that you're not sure of, please make sure that you let me know. Okay. So again, good luck. Let me know if anything pops up.